into a recording because it's not. So for this problem, the work is the answer. Like the final answer here is not much credit. It's all the work in between that's most of the credit.
Oh, we actually had to get to the
Yeah, you need to get to the answer.
Really?
So what has to happen is these two, everything must connect to each other. So if these two don't match, that will be wrong. If the first step, if the last step and the second to the last step, they don't match, then something's wrong. So when I ask you to use the definition of a derivative to find the derivative, this is the process I'm looking for. Yeah.
What if we just like stopped at the first step? Like, how do we know when we have to do it?
What?
Like, I got like limit of 0 looked as like blah blah blah. Like, why is it that button?
I didn't understand the blah blah blah.
So like, you see the thing you put first?
This? Yeah.
Like, that's what I did. Yeah, that's what I got. Is that okay?
That is inadequate.
Really?
Right.
How do we know?
Because unless you can say, no, you got to be able to go from here to here.
Is it
But how do we know when we have to like actually do it?
When it tells you to find a derivative using the definition of a derivative. When it's in the instructions, find a derivative using the definition of a derivative.
do it?
But like
Until you don't have a limit. See, there's no limit on here.
oh, from the limit.
Okay, so are you going to provide that F?
No.
So I have to just know that?
Yes.
No what?
This.
Oh yeah.
All right. Now, this is not the only way the question is going to come up. This is not the only way the question is going to come up. Another way where the question will come up is it'll be multiple choice where I will have some version of this for some function. Say, for example, let's say I did, let's say the function is sine of x, right? And then I will say which one of these matches the derivative of this. And so I might have something like sine of x plus h minus sine of x over h. Is that a correct application of the definition of derivative? Huh? No, why not?
Because it doesn't look right.
Because it doesn't look right.
Like, if you were to solve it, that would.
Oh no.
Why?
Because you need limit. I think.
Because you need a limit.
Oh.
That's going to be the biggest, or the most common mistake, is that you left off a limit. You have to have a limit. You can't just write the difference quotient. Yes, Matthew.
So as we do every equation, how many points, like, is it completely wrong if we don't put limit as h goes to 0?
No, you lose notation points. Now, if you start without the limit, then you lose the points completely. So if you started with the limit sign, but then you just left it off, you would lose points for bad notation.
But if I don't put limit at all, then I'm good.
If you don't put a limit at all, then it's just wrong. Yeah.
Oh, just wrong.
Okay. So it's
Because you didn't never use the definition of a derivative.
Okay.
Okay. So that go ahead.
What's like an example of a function that you can only find the derivative using this process?
Well, once you found the limit, then you just make up a rule. So there are none.
But then you
Because
say that there's-
once you do this, then you have a rule you can use. Like even the product rule can be developed using this. It's a really complicated one, but you can use it.
But like, didn't you say there's like some functions that we can't solve just using like the easier?
Right. But once you've got it, then you have a rule. Like there's some functions that I don't like. What? Like the greatest integer function. I don't know what the rule is for that one. Right? But once I do this, then I might have a rule. Or I won't understand what the rule is and have to keep doing it this way. Right? The greatest integer function is this.
What's the greatest integer function?
The greatest integer function, you guys ever seen this thing? So f of x equals that. Right? The graph of it looks like this. Yeah.
Oh yeah, I've heard of it.
Right. What's the derivative of that? Well, it's actually not that bad. The derivative is 0, except sometimes. Except at these points of discontinuity, right? Then it's undefined. All right.
Wait, what happened? I got to
Oh, that makes sense.
Right, because they're all horizontal lines, so the
I ran out of
derivative
room
is
on my
0.
paper.
What is that?
Copy down the right answer.
This,
Is that like a?
Dude, I just gave up on this paper.
that's the greatest integer function.
Oh, okay.
That's the greatest integer function.
I would, but then I would get lost.
So it's like absolute.
That's why I get to.
No, that's the greatest integer function. This is not absolute value and then put brackets. This is bracket with a weird line in the middle.
So what does that mean?
Weird one.
What does that mean? If it doesn't help me, I don't know what that means.
It's not
Okay, you ever
really-
heard of the floor function?
No.
The floor function and the greatest integer function are the same thing. That means if I have, say, floor of 2.9, that's 2. Floor of 2.1 is 2.
So what is the weird line for then?
So just because it's the X value.
That's just a notation for it.
Oh, okay.
Don't worry about it. If it's on the test, I'll change it. I don't like the greatest integer function myself. All right, here's number 3. This one you're just finding the second derivative, so you just have 6x plus 8. All right, number 4. Find the point on the curve at which the tangent line is horizontal. The final answer is negative 3 halves, negative 19 fourths. No, that's not it.
Negative 37 fourths.
Negative 37 fourths.
Because you had to plug in 3 halves or whatever.
Yeah.
3 halves.
Yeah.
I got 9
Point.
I got that horribly wrong, but I think I just
Wait,
got
where
it or something.
21 come
Just
from?
don't do that on the test.
Say it again.
Swat, where 21 comes from?
That's what shit.
Where do you see 21?
The comma looks like.
Oh, never mind.
But, so negative 3
No, I didn't get that
times
right.
negative
That's right.
34 sevenths.
Yes, that's right, Lee.
Whoa, I don't know. It's negative 3 halves, comma, negative 37 fourths.
Yeah.
All right, number 5. That's this thing.
That's right.
So you're given the point 1, 3. So there's the 1, 3.
Yeah. You gotta plug
So
in.
you had to find the derivative to find the slope. So the derivative, you plug it in, you get 2, so that's the slope. And that's adequate as an answer. Of course, if it's multiple choice, they might not stop there. They'll probably go as far as y equals 2x plus 1. So equally likely to go this way or this way. Nothing in between. Either the top one or the bottom one.
Would that have a? So would there ever be a question where it says
Oh, wait, no.
Hold on.
which answer is most simplified, and it would have?
No,
the
that's
bottom-
not that. No, that's an algebra question. That's not a calculus question.
You have to plug in one. So it's simplified.
I was looking at the answer for 6. I'm confused with that.
All right. So the equation of a line looks like this, right?
Yes, sir.
So y1, m, x1 are all numbers, yeah? So this right here, f of 2 equals 6, that tells you x1 equals 2 and y1 equals 6. If they tell you the derivative is negative 3, that tells you the slope is negative 3. So you have all the information you need to fill it in. So you just fill it in. So this question is, do you understand or can you interpret the information you've been given? This is the ordered pair, 2, 6. This is the slope at x equals 2. And they're asking you, what is the equation of the tangent line at x equals 2? All right, number 7. Derivative. I got this, and then I simplified it. Well, I don't know if I'd call this simplifying.
It just looks stupid.
It does not look stupid. It looks better. Factored form is usually better, but I don't know if that's really any better. Okay? So I can't tell you one way or the other what would appear on a
Easy
multiple
factor,
choice.
how come it wasn't negative e to x?
I switched the order.
See, that's just confusing. You're gonna ruin me.
It would be easier once you know it.
Yeah, math people don't like to start with the negative, okay? Math people don't like to start with the negative. So he wouldn't take out the negative sign. He would just switch the order. Right, you'd only take out the negative sign if both of them were negative. Okay? Alright, so they prefer cosine x minus sine x versus negative sine x plus cosine x. Alright. But that's just a math bias.
Yeah. Do you consider yourself a math person?
I give myself an Okinawan. Alright.
Well,
Okay, so the final answer I got was this one here. 3 minus 3x squared over x squared plus 1 quantity squared. If it is a multiple choice question, this one is the most likely answer. Okay?
so do we have to simplify it?
Didn't I just tell you why that's the answer? If this were a multiple choice question, the most likely answer is this one. If it's a free response question, you can just stop here.
Because it's gonna say
Wait, so
an equation, so that means
Right.
it's an equation.
Right.
Yeah.
Blake,
so if it's a free response question,
yeah, if it's a free response, stop there.
only put in the information.
Yeah, only answer the question. Don't try to simplify.
Yeah. That'd be good.
Okay? Of course, if you have like 3 minus 3, you should probably simplify 3 minus 3. But this, don't simplify this. Right, if it's a free response question. By the way, though, this is highly unlikely to be a free response question.
Wait, why?
Because it's just mechanical. So free response questions are more deep questions. Like, do you know this theory? Multiple choice questions, these are more likely to be multiple choice questions, where you just find the derivative. Yeah.
So on the top, did you cancel out the x squared plus 1?
Okay. You're talking about these two, right?
Yeah.
Okay. No!
Oh, whoa, that was scary.
That was the intent. I wanted to be so traumatized that you will never ask that question again. Alright, let me explain what happens, okay? So she asked the question. I wonder if I broke the computer. Alright, anyway, because this is being recorded. Anyway, so if I have x plus 2 over x, your question is, can I cancel these two x's?
No, because
You can't. Right. Whenever something's being added to something, you cannot cancel it. Okay? By the way, I know she's not the only one who was thinking that.
What about subtraction? Same thing.
Addition or subtraction, you cannot cancel.
So that
It's like saying 1 plus, let's do something else. Let's say 3 plus 2 over 3. You're saying that's equal to 2? Because the 3's would cancel with your idea, right?
so h squared.
Right. So you have to do order of operations. This must be reconciled before you can do any reducing. Okay?
So if I had h squared minus 4h over h, that would be h minus 3h.
Huh?
If I had h squared minus 4h
You see it? It's just here.
over h.
That would be h minus 4.
It's not h minus 3h. Oh.
All right. Did I answer your question though?
But where did it
And-
go?
Oh, so you thought I canceled it to get here?
No, but like.
I was the same about.
Okay. So what did I do? I multiply this out. So that would be 3x squared plus 3, yeah? I multiply this out. That's minus 6x squared. Right? So 3x squared minus 6x squared is minus 3x squared.
We're one and one of them.
Wait, that doesn't make sense. Because if you have h squared minus 4h over h, can't you take an h from both?
Right. But you don't take a 1 from the 4. You just take the h off. Right? So this becomes h times h minus 4 over h. Right? So the h is canceled. So you just have h minus 4.
Oh, wow.
Alright. Okay? Number 9. So number 9 is a very good multiple choice question because they want to know that you can get here. Like this is a really good question for that. The final answer here was negative 2 sine x over 1 minus cosine x quantity squared. Okay? Yeah, you did this with me on Friday.
You know, you didn't.
Okay, I won't do that again.
Wait, what problem are we on?
9. So yeah, so this would very likely be a multiple choice question.
It's a good one.
But can you
In fact, that might be straight off the test.
Can you show us?
Yeah.
Okay, so here's the quotient rule, right? This is the quotient rule.
Yeah, that's
So you
like-
take the denominator, bring it up, times the derivative of the numerator. So the numerator is 1 plus cosine x, right? The derivative of 1 plus cosine x is negative sine x, minus
Straight off the top?
the derivative of the denominator. The derivative of 1 is 0. Negative cosine x, the derivative of negative cosine x is positive sine x. That minus sign is because it's the quotient rule.
Oh, so then you should put that.
and then times 1 plus cosine x, which is the numerator.
That's
Right?
confusing. I think it's
Okay,
negative sign
and then you just distribute or simplify. So here, actually I didn't do that. What did I do?
something.
I factored out negative sine x? Is that what I did? Alright, so I factored out negative sine x, and then this was a mess. Right, so I had to do the rest in my head, because it didn't make sense.
What do you mean factor out?
So let me tell you what happens when I factor out negative sine x. So let me copy the numerator, okay? All I'm doing is copying the numerator. Alright, so the numerator I have is 1 minus cosine x times negative sine x minus sine x.
Can you put that at sign?
I tell you what though, factoring out the negative sine x is probably more algebra than you want to know how to do. Okay? Huh? So I'm just going to distribute. So that'll be negative sine x plus sine x cosine x minus sine x minus sine x cosine x. Yeah? So these two cancel. So you got negative sine x, negative 2 sine x. Over the denominator, which didn't change, right? Which was 1 minus cosine x squared.
I want to know how you would factor the sine x.
No.
I'll do that in a minute, Robert. Okay? So you can multiply it out without doing what I suggested.
It's so confusing.
There's actually not that.
Where's blank paper?
Oh,
Look at piles of paper.
I'll figure it out.
Huh? Okay. So the question is, how did I factor out a negative sine x? Alright, so I'm doing this technique number 2. Alright, so there's a negative sine x here and a negative sine x here. So I take out the negative sine x. So for this part, it leaves me 1 minus cosine x. Yeah?
Yeah.
So when I take a negative sine x out of here, that turns into a plus. Yeah? So it's
Yeah.
plus 1 plus cosine x. Yeah?
Yeah.
So the cosine x cancel and I got 1 plus 1.
Huh.
So that's how I got negative 2 sine x.
No, it's actually not that deep.
That makes sense.
Okay?
That's very simple.
Alright. The thing was, that one I can do in my head. It's doing it that way, I can't do it in my head. That's why I went from this awful mess to, oh, I just have this. Alright.
Wait, go back to the other work again.
Which work? This one?
The white paper.
Mr. Spencer,
Matthew.
would the equation change if it was 1 minus cosine x or 1 plus cosine x?
Yeah. It might be negative 2 sine x cosine x over 1 plus cosine x squared.
Right.
But I'm not sure. I'm just guessing. I'm just thinking the different thing would cancel.
That's not a good thing to hear.
Alright. Number 10 is a question of, oh, do you know the derivative of cotan and cosecant? That's all that is. There's no work to do. Is, do you know the derivative or not?
So if it's y over copy and data, that just means find the derivative.
Yeah, that just means find the derivative. Okay, or you can reinvent the wheel. What do I mean by that? Rewrite cotan theta as cosine over sine, and then do the quotient rule on it. Rewrite cosecant theta as 1 over sine, and then do the quotient rule on it. And then hope you can simplify it to the multiple choice answer that will look like this.
So that's what X.
You don't remember.
Yes.
The
The only problem is you may run out of time.
That makes X into
We've got 15 minutes. I think it'll be okay.
I do that.
Yeah, but you have 14 other problems to do.
We have 15 minutes.
Well, that won't be last.
Yeah, do it last.
Oh, I got you.
Ox one of the easier ones, but if I would just put the X in
Put a
for
little star
delta,
by
would it be wrong?
Same.
Oh. You mean theta, right?
Theta, sorry.
With me grading it, I won't notice that you changed variables.
Okay.
With AP grading it, yeah, you should probably. Or if you somewhere earlier you said x equals
Yeah, that's
theta,
what I'm gonna do the whole.
then they'll take it.
Okay.
But if you don't do that, they'll say, oh, he's got it wrong. I mean, I don't know how picky they are about that.
Oh, yeah.
But if you did that, then you're safe. Yes, Kedrick. Derivative of tangent is secant squared. So that's 11, right? That's product rule with negative x times tangent x.
Yeah, some type of shit.
Oh, I know what page it's on, hold on.
Alright, ready to keep going?
It's 102.
So we're on a 12?
12. So I didn't simplify that one at all. Mostly because simplifying didn't really help it that much. So if this got simplified, only thing it would look like is x squared cosine x plus cosine x minus 2x sine x, and that really didn't help it.
At least you know the denominator is generally not going to change.
Yeah. So when you multiply that out, nothing really happened, right? It's just x squared cosine x plus cosine x. That's not any better. Yes, ma'am.
Stupid question, but like for the original, if I put negative sine x times 2x, would they mark that wrong because it's not the front?
Nah, that's okay. No, there's nothing wrong with that. All right. 13. So this was a mess. So chances are I made an arithmetic error here, okay, or a substitution error. So if your answer disagrees with mine, let's talk about it, okay? Don't just assume I'm right and you're wrong, okay? So here, so for h of x equals f of x times g of x, that requires the product rule. So h prime of x is that, right? Remember, you apply the product rule. So h prime of 2, and that's what you're asked to do. You're asked to find h prime of 2 for all three versions of h. So you're going to go h prime of 2, so you're going to plug in 2 into here. So f of 2 is 1, that's where that 1 comes from. And then g prime of 2 is 3, so that's where that 3 comes from. Plus f prime of 2 is negative 3, and g of 2 is 5, so that's where that 5 comes from. So that's 3 minus 15, and that's how I got negative 12.
Got that answer.
Congratulations.
I'm just saying, you said you want to mess stuff up. So next week you got
Alright, B. So this is one's quotient rule. So that's what quotient rule looks like for f of x over g of x. So I'm doing g of 2, which is 5, so that's 5 comes from, times negative 3, or f prime of 2, which is, where'd it go? Where's f prime of 2? There we go, negative 3. So that's where the negative 3 comes from. Okay, so I keep going to these numbers. Are we ever going to use those? No. So these are distractors.
Wait, why?
Because it says f prime of 5.
And h of x is equal to what?
We're doing h prime of 2, and none of these are going to use a f prime of 5.
But where does it say we're doing h prime of 2 and not 5? Where does it say we're using 2 and not 5?
Here, find h prime of 2.
Are they gonna do that a lot?
Actually, I changed one of the questions where you needed a 5.
If they're completely different functions, why do they have to be the same value?
That's not
If like h, g, and f, they're all different functions, why do they all have to be 2?
Because h is different from problem to problem. Right, h's are different. F and g are the same, but h's are different. So from each problem to problem, f of x and g of x are the same functions. But h of x is different from problem to problem. Right? This one is the product, this one's a quotient, this is some weird linear combination. Alright. So minus g prime of 2, which is 3, and f of 2, which is 1. So it's negative 15 minus 3 on top, which is negative 18, and g of 2, which is 5 squared on the bottom. So negative 18 over 25. This is a very APS question, where they give you this information and they want you to do it symbolically. They could give it to you this way, or they can give it to you as a table of values. Or they can give it to you in a graph. I think that's like problem 16. They give it to you in a graph in problem 16.
I'd rather have the table. Table's more realistic.
I think the graph is more realistic.
Well, see, the graph didn't give me the derivatives of the functions. Whereas
Yeah,
the
but
table-
since the graph was just line, derivative would just be the slope.
Oh.
Silly rabbit. Alright. This one is the easiest problem because all you gotta do is 2 times f prime of x plus 3 times g prime of x. So 2 times f prime of 2 was negative 3 plus 3 times g prime of 2, which was 3. Right? So negative 6 plus 9 is positive. So did I get them all right there, Robin?
I got that one on. I got 3 lines different.
Did I do something wrong? Did you do something wrong? Blake, where'd I get this to?
No, you don't have to use product rule for that.
Nah. That's the constant multiple rule.
Oh, right, I remember that. Which means
Like-
the constant just follows the.
I'm confused. Like, how do
I
you
need
know
more
when to
information.
use-
Huh?
How do you know when to use f derivative of 2 equals negative 3, and how do you know when to use f derivative of 5 equals negative 1?
Because this says to find h prime of 2, right? That's in the direction. So that means for every place there's an x, you put a 2 there.
Yes.
Okay.
That's why it's f prime of 2 and not f prime of 5, because you're putting 2 where the x is.
But is that just extra information or what?
Yes.
Oh. Okay.
I also changed one of the problems. I just forgot to delete that extra information. Like C was not this originally. C was chain rule, but we haven't covered chain rule.
Was it? It was. I don't think it was asking for the derivative, was it?
Which one?
Like, okay, you put. I probably did this wrong, but you put 2f prime of x. I just had 2f of x.
Yeah, but the direction says find h prime of 2.
Oh, I was looking at just the h of x equals 2
H
of x.
prime of
So-
2.
Right, but it was h prime of 2 for all of them.
Oh, I was just looking at the h of x.
Because if it was
I thought
just
we were doing
h
that.
of 2, then we would just plug it in.
Ah.
Yeah. Yeah.
When do you use chain rule?
I'm not going to answer that question because we haven't gotten there yet. And there is no chain rule on the upcoming test because we haven't covered the topic yet.
That's just tomorrow.
Test is tomorrow. But there's no chain rule. Don't worry about chain rule. All right, 14. You know, usually this little menu on the side goes away. Why doesn't it go away today?
Let's go, baby. I got one.
Whatever. Now it's on the right side. All right. Okay, that was 13, 14. So here, plug in 0 to this expression. When you plug in 0, you get 0, 0, right? You get 0 here and 0 here. So it's continuous at x equals 0.
So I have to say that x equals 0.
I had to draw the
Right.
graph, but it worked. Because I remember.
How do you get 0 outside of x? Or cosine of x?
Huh?
Cosine of 0.
Whoa. I didn't say I got cosine of 0, 0. I'm plugging in 0 here. I plug in 0 here to get continuous at x equals
Sine of
0.
x is
The sine of 0, 0 or something?
Sine of 0 is 0.
cosine of 0.
But cosine of 0 is 1, not negative 1/3. So that means it's not differentiable at x equals 0.
Yeah.
So do I have to put at
But
x
Ben,
equals
be
0?
careful. These were non-calculator questions. So if you had to use a calculator to graph these functions,
I knew sine had the squiggles, and I knew 1/3, negative 1/3 x went that way.
okay, that's fine.
Wait, so I have to put x equals 0?
So you said.
Yeah.
So why was your answer continuous at x equals 0
That's what you plugged in.
and different?
Because that's the only place that it could fail, right? Because negative 1/3 x is continuous everywhere. Sine x is continuous everywhere. So the only possibility that it could fail to be continuous is at the boundary.
I just said continuous, but not different.
All right. And 15.
It's like work.
So it says find position when t equals 2. Then all you're doing is plugging 2 into this expression.
No? So if I took the derivative of that, that's the acceleration?
Yes, that would be velocity. No, that's not acceleration. That would be velocity.
And if I take the derivative of the derivative, then that's,
That's acceleration.
That's light work.
Gabby?
I get A wrong. Did I plug it in wrong?
Yeah, no.
It's possible that I plugged it in wrong.
I got 164.
Okay.
Yeah, 184.62.
Okay, 3 different answers. That's not good.
Yeah, I don't know what happened.
I'm putting it in
I mean, I did plug it in,
We'll
but
plug
I
the
probably
graphic
did.
calculator.
Alright, so let's see. So I'm going to use the calculator for this. So notice this is a graphing calculator permitted problem. So I'm going to plug in, what is it, negative 0.81 x squared
It is 161.76.
plus 59x
Oh, that's the answer. You had it
plus
right.
47.
I have 167.
Second quit.
You had it right.
I do alpha y1. That gives me y1. Your calculator knows interval functional notation, so I do y1 sub 2. Press enter, and I got 161.7.
Oh, that's
what
Oh,
you're right.
You have to do all
You put it in the Y.
Or you could just play the
Yeah, but that lets me plug in everything else. Like next one is like at 12, right? Isn't there one at 12? Never mind, I don't see it.
No, it's not. 12.
Okay, it's not this problem.
I just put it in a
Well, no, you don't have to do it that way, but if you have a problem where you got to plug in several numbers, so then let's say I want to plug in 12 now, I just bring that back. Oops. Bring that back and just change it to 12.
Or you can just have the other one and then just copy the one that you put down and then.
Yeah, you can do that too. But then you have to change all the instances
Yeah,
of
so
2.
that's like 3.
And this was 1.
Oh, yeah. But I mean, I still think it might be faster, especially if you have to learn that.
Learn it. Alright. Okay, so I guess I'm the correct one.
Yeah, you're right.
Yes, you are, because I didn't know you could do that special trick.
Alright.
Done.
And then, plus, there are other benefits to plugging it in here. What if it asks you to graph it? What if it asks you to do other things, right? Or what are the x-intercepts? Like here, if you graph this, now you can look at where the x-intercepts are.
Which is where it goes to 0 and x.
So if it's 1.
Right, there's 2 x-intercepts.
Where's the second one?
Wait, can you show me about how to get back to the? No, we did it before, but I forgot how to do it.
Get what?
To where you could just like go back and plug it in.
The Y1 stuff.
So all I did was push the up arrow.
No, like.
How'd you get to the
get
Y1?
there? Like, I forgot what buttons you pressed.
So I did alpha trace,
Alpha trace.
right?
And you just.
Whoa, my screen just froze. There you go. All right. So alpha trace gives me this list of y values. And then I press enter on that, and then I use parentheses.
I like that too.
Me too. All right. Oh, here, see? You have to do it here. You got to find S sub 1 and S sub 3. So that's what I use. I just use this calculator and that notation.
I'm just going to go and plug them all in.
You do that. I mean, there are other ways to use a calculator. You can just go to the table, right? You can go to the table if you want. If you don't want to do that.
Wait, so you don't.
I'm listening.
I thought you just did the
Derivative.
That's for.
So average velocity is just a slope between those 2 points. So you just plug in that 1 into S and 3 into S.
So do I do 1 minus 3 on the denominator?
You can have that, yeah.
This is the denominator.
Monominator.
Oh wait, but you did the top backwards.
I did?
Yeah, you solved for 3 and then solved for 1.
Yeah.
So
So S sub 3 minus S
I
sub
did
1,
1
3
minus
minus
3 and then 1 minus 2 on the bottom, so the same.
Oh yeah, that's fine.
Okay.
Well, you got this.
Yeah.
The only difference will be the sign if it's wrong, right?
Right.
All right. So C says find the velocity. You just take the derivative of position.
I got 62.24.
Huh?
Right.
What are you talking about?
For number C on 15.
C? You got 62.64?
Yeah.
It's just asking for the velocity equation, so there, it's not
Oh,
a
sure. I
constant.
plugged something in.
Right, don't plug anything in. It just wants the equation. Number, or part D, they want you to plug in 3.
Oh, I plugged in 2.
It says 3 though.
Oh wait, you got negative 1.62?
Uh-huh.
So that's how you get.
That's what I did.
Because 2 times 0.8 is 1.6, right?
It's actually really easy.
So what's the
It's a lot of mental mistakes.
54?
54.14?
That's right.
That's what?
That's D. That's
That
B of
is
3.
the instantaneous velocity at when.
I got like 60 because I put positive 1.62 or whatever.
Oh, I see my line broke. I didn't put a
It's not
negative
hard.
one.
It's just.
So E, you could have used the quadratic formula, or you could just look at the graph. So you can't go backwards in time, so you're going to reject that one. And then you go, oh, so the answer must be way over here somewhere. So you go window and hope for a bigger number of x. So let's go 100 for x, and then graph it. And there's the other one, right? And you're allowed to do second calc, and go for the, what is it, 0.
0, number
Find
2.
2. Left bound, I have x equals 45, that sounds good. And then right bound, so I just pressed enter way over here. Now I want x to be on the other side of that, like close to 100. So I want to go, so if this is 45, then this is about 80-ish. So I'm going to go higher than that, so I'm going to go to like 90. And then press, huh? Oh, and then, or you can just pay attention to the y values and not go that far.
Yeah.
All right, press enter on that, so it's there. I'm going to go a little bit towards the center, and then press enter. And it gives me 73.6275 now. So you do not have to use the quadratic formula. You could just use the calculator. If it's calculator active, that is perfectly legitimate.
And so the answer is you say 3 point.
And it's nice to confirm that I've got the same answer. 73.628.
And you did it all with the graph.
Okay.
It takes a lot more.
And then you plug in 73.628 into the velocity.
You really need a graph calculator out here.
What's the answer for E?
73.628. I think the graphing calculator would have been a better choice for E, because when you get the answers out of this, the answers are confusing. Because you would think the negative will give you the incorrect answer, but it's the negative that gives you the correct answer. Because you have a negative in the denominator, so you need a numerator to be negative.
That's what I did, but I guess I'm different.
I agree with this.
How, like, what's the most common mistake when
So how'd you-
that whole thing? Like,
Typing it wrong. The most common mistake is just typing it wrong.
Like how?
Like you left off a decimal, or you write a 58 instead of 59. The most common error is just copying yours wrong.
I graphed.
Like a lot of people get this correct and then screw up the calculation.
Yeah.
The good news is you get almost full credit for this step if it's free
Okay.
response. And then you only lose like half a point for the answer.
In the quadratic formula thing, is that a 47? Wait,
Yes, I believe it is.
Yes.
I graphed it.
and then that's a 4. Wait, well, why is it switched? Because like
What do you mean
usually the
switch?
4 is on the outside and it's like -4 times A times C. So why is the 47 and the 4 switched?
Is 2 times 3 the same as 3 times 2?
Yes.
So I forgot the 4, and I wrote 47. So I remember the 4 after I wrote the 47, so then I wrote the 4.
Okay.
Is,
And notice, that's A, right? A is negative 0.810. So I wrote the C, and then the 4, and then the A.
that's 4 I see, but he did see it.
Yeah, sorry.
Is 0.81 the same thing as 0.810?
Yeah.
Yes. Mr. Richard?
Right, if you wrote 0.81, you'd still get full credit. Yeah.
So what was the next step to get change the X to main or whatever?
What?
So I got the graph, but I need to change so I can see the X where it is 0. What did you get? You said second count?
Oh, second calc, yeah.
Where's count?
This thing? Calc is the second button from the top.
Oh, okay. And then you went to 0.
Yeah, 0.
Oh, but how'd you get the, how'd you get that range?
Okay, you go to the left bound. So you want to go obviously left of this intersection, right? So obviously left would be like over here. Like if, remember, so you got to remember that you went from 0 to 100. Also, look at the y value. It's positive. So press enter. Now you want the y value to turn negative. So now it's negative, so I can press enter on that. And then press enter. And that'll give it to you.
Yeah, but how'd you get the thing? Like, how'd you, remember you changed it to 100, like 101 or whatever, 100 the X to main. How'd you do that?
I go to window,
Okay.
and I changed X max to 100.
That's 15. Okay, thank you. Next problem.
Alright. So F was find the velocity of the cheese when it hits the ground. So all you had to do was plug in the 73.628, the answer in E into this. Now, this is how free response grading goes. Let's say you got this number wrong. But if you plug it into the correct thing, you get full credit for F, even though you lost a point for E.
Plug E into E? No.
You plug the answer of E into F.
What is F?
Problem F.
We didn't answer F yet.
Well, F is the velocity equation. What I'm saying is, what if you got this wrong? Do I lose the next question because I got that wrong? No.
Wait, so
Okay.
what form
As
of-
long as you plug it into the velocity equation. The velocity equation was the answer to C.
C. So plug E into C.
Sure. To get F.
C. Yeah. Fair enough.
All right. And then it says in G, find the acceleration due to gravity.
Yeah, what is that?
So you take the second derivative, and that gives you negative 1.62, and that's the acceleration due to gravity.
That's
This way?
So anytime we're solving for acceleration, it's in terms of gravity.
Say what?
Anytime we're solving for acceleration, it's in terms of gravity.
When it's this kind of problem.
Okay. So on the test, where you get some of the problem like this. So
That's
like,
probably the free response.
like when did the basketball hit the ground?
Yeah.
Okay. Something like that.
Or what's the velocity when it hit the ground?
Okay. Yeah, that's just light work.
when did the cheese hit the ground?
That's a bad problem. A piece of cheese is done.
All right, find this time when the cheese reaches its maximum height.
Yeah.
How hard are they doing this cheese?
So that's when I set the velocity equal to 0. That gave me t equals that. And then I plug that into the position function again. So that's the fourth use I have of the position function, right? So it was helpful to plug that into the calculator.
So you set C equals 0.
I set first derivative equal to 0. Oh, so yeah, C. So C, yeah.
So then it comes out 1121 or something. Is that the final answer?
Yeah.
Or 66 or 36.
11, 21, 383.
420.
Wait, why just tell me about 420?
Huh?
Why'd you type it in 420?
It's I plugged in 36.420
Into what?
into the position function.
Position function. Okay,
So that's what that S stands for, the position function.
so 420. And then, well, that's the original function.
Yeah.
And that equals 11. That sounds kind of high.
Yeah. That cheese flew over a kilometer into the air. Yeah.
So like a
Hold on. Which letter?
T. It's A of T.
A of T is the derivative of V, right? And it was negative 1.62?
Yeah.
So that's the acceleration due to gravity.
So the answer to H was,
By the way, if you gave me negative 1.62, I'll still give you credit. Or if you give me positive or negative, I'll give you credit for 1.62.
so what was the answer to H?
H?
What was up there?
H is 1121.33.
Why is it?
That's the 1 kilometer high piece of cheese.
Oh shoot, I did it wrong. I did it wrong.
Oh, I'm really angry at that piece of cheese.
Where's, can you slide up a little bit?
I don't know what that means.
No, 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 no. Go the other way. So I can see, okay, negative 1.
Alright, 16.
Oh, yeah.
Alright,
Just give us the table, please.
no, definitely one of these on the test. So, if you got h of x as this function, use the product rule to find the derivative. F of x, or let's see, this is looking for 1/2. So what's f of 1/2?
Just leave partial credit.
F is this one, so f of 1/2 is here. So it's like 3/2. Oh, sorry. So f of 1/2 is 3/2,
That's right.
or 1.5. You can just estimate it, okay? And then it says g prime of 1/2. Well, here's g. What's the slope here?
It's 4.
The slope is 0. So here's the thing. It didn't really matter how bad you were on your approximation, because 0 is going to wipe out your approximation anyway.
It's actually 0.
We're moving the test to Wednesday.
So it's like, this is my job to make it up there.
I mean, it's light work. I can take it home, but
Not everybody has excellence in algebra.